This week we are going to talk about a lot about the arcs on circles, but we're going to talk about the length and some other stuff about arcs. So this video is about just how to find the length of an arc. You recall that we've talked about finding the measurement of arcs as just like angles, like they match the central angle. But you can actually measure an arc in two ways. You can find the length of the arc as well. It's just a portion of the length of the entire circumference. And just as a quick review, remember the number pi, which we all know and love, 3.14159265358 and so on. That number is just the ratio between any circle's circumference and its diameter. And when you solve for c, that's why you get this c equals pi times diameter. So we're going to use this a bunch because when you find an arc length, it's a lot like when we found shaded area way back in November. You have to figure out what portion of the circle you're looking at and then multiply it by the entire length of the circumference, and then you get the portion. So I have 3 examples set up, and we're just going to go through them. And you know what? Finding arc length is exactly like that thing. Remember theta over 360? That's just the fraction of the circle that you're talking about, and then you multiply that by the entire circumference. So the main difference between that lesson and this lesson is this here is circumference instead of area. So this says find the measurement of arc BC is 135 degrees, so find its length. Well, that means it's 135 out of 360 degrees. So that's a certain proportion of the circle. And then we're supposed to multiply that by the circumference, because I want to know the length. And it says here that the radius of the circle is 8 inches. And right off the bat, that tells me that the diameter of the circle is 16 inches. And so that would be, I'd multiply that by 16 pi. Now, I could get out a calculator and calculate this, but what I want to work on today is expressing these values in terms of pi, so that we're not estimating, but we're just leaving the pi as part of it. So the first step then would be to think about how can I reduce this fraction? And you know, I already know the answers and I like to keep the videos short, so I'm going to tell you that 135 and 360 both have the greatest common factor that they have is 45. And when you divide the top and the bottom by 45, 135 divided by 45 is 3, and 360 divided by 45 is 8. So that's 3/8 of the circle, and I'm going to multiply that by 16 pi. Okay, but when I'm multiplying a fraction by a whole number, remember, I can do this cross-cancel method. 16 divided by 8 is 2, and 8 divided by 8 is 1. So I can cancel the 8 with the 16, and then, I can cancel the 8 with the 16, and then all I have to do is multiply 3 times 2 pi. You know what that is? It's 6 pi inches. You could get a calculator out and actually do that. It's like 18.8 or so. But that's all I want to do is express it in terms of pi. Okay, here's another one. Find the length of arc EF. So I know that the central angle is 70 degrees, and that's out of a total of 360 degrees. And then I'm supposed to multiply that by 18, because the diameter is 18. If the radius is 9, then the diameter is 18 pi. I want to show you another trick. I mean, it just makes your life a lot easier. 70 and 360, I don't know if they have well, they do have one common factor, it's 10. And that just means we can cancel out the zeros. So I'm finding 7/36 of the entire thing. And then I also note that 18 divided by 18 is 1, and 36 divided by 18 is 2. In other words, 18 over 36 is just 1/2. So what am I left with? 7 times pi over 2. So I could say it's 7 pi over 2 centimeters. And that's how I would leave my answer. It's 7/2 times pi, 3.5 times pi, but let's just leave it like that. All right, one more. It says, find the length of major arc XYZ. And you notice that I gave this central angle is 100, and so if you just think about it, that means that this angle has to be 260 degrees. So I'll do 260 over 360 as my proportion of the circle, and then I'll multiply that by 10 pi, because if the radius is 5, that means the diameter has to be 10. And now let's see if I can reduce this and make anything out of it. Well, of course, the zeros cancel, and you'll also note that 26 and 36 are both even numbers. So let me reduce that fraction by dividing by 2. That's 13 over 18 times 10 pi. Okay, and then let me think, is there anything else? Well, 10 divides by 2 and 18 divides by 2, so let's do that. I get 5. When I divide 10 by 2, and 18 divided by 2 is 9, so I cross-canceled those. I don't think there's anything else I can do. 13's prime, so I just multiply now. 13 times 5 pi over 9. 13 times 5 is 65, and then pi over 9 feet. And that's as far as I can take it. That's 65 pi over 9. So yeah, now try to find those arc lengths on today's assignment.